All right, welcome back to another video. This time we're doing homework 4 to help you. First problem is this container. So we want to find FR in the location of center of pressure of this triangular window. Now this one is submerged at an angle. So what I would do first, remember it's at an angle, so you have to use the coordinate system Y. So I would draw a line right up to here, and then draw a line from this over, and that is where, in perpendicular, this is where your Y value will be. Okay, so you have, I'm going to draw right here on the sketch, perpendicular down to here. That would be called YP. And then here, this is YC. Okay. Now, the dimensions aren't probably perfectly correct. Let me check. Let me move. Let's see. I can give you some numbers here. YC should be 3.94 feet. And you'll end up with YP being close, 3.98 feet. Okay. So again, not to scale, but that's okay for right now. You can just make the sketch. All right. So we know that FR is P average times the area. We can find the area of the triangle, okay, which is base times height over 2, okay, or 1/2 base times height. We know P average is rho GHC. So we just have to figure out, if I do this and I go over that value, okay? So the way we can find it is we know the angle is 50. As long as we have theta and we have YC, we can then find HC, right, with trig. The trick is, how do we find YC? Well, from here, actually, let me use purple. From this point to the top of the window to where this is, okay, for a triangle, that distance is 2/3 times L. And L is 20 inches in this case. All right. So that's where YC, or where that would act on the window. Okay. But we also have from here to here, which is 6 inches. And I'm going to label this YC. And then from here to the free surface here, this dimension we need to find. But we also know, I'm going to call this H1. We also know, let's do light green, that from here up to here is 18 inches. And we know theta, which is 50. Okay. Which should be right here. We can use trig then from the 18 inches and 50 to figure out H1, which is this. Okay. And that should be about 3.9 feet. So the recap, you have to create the Y coordinate system. Draw a line down, label it YC, draw another line, label it YP. Okay. And this is where FR is going to act perpendicular to that. we know that FR is P average times A. We know P average is rho g HC, and we need to figure that HC value out. And what we need to do is we need to find out how far down YC is, which is from this X part to here, which is you need to use trig with the 18 inches in theta. We know that this distance from here to here before the window is 6. And with a triangle, I'm giving it to you now, from this point to where the actual centroid would be is 2/3 times L, and L is 20 inches. So once you find that value, you can then use trig again, and we can find HC. And then we know that YP is going to be YC plus IC divided by YC times A. And for a triangle, IC is, and you can find this in your book, WL cubed over 36. So you can go ahead and find your YP value. And then you can use trig again to find HP. Okay, did it tell you that? Nah. You can just label YP and that's fine. So that should help you with problem 1. Problem 2, it says a room in the lower level of a cruise ship has a 30 centimeter diameter circular window. If the midpoint of the window is 4 meters below the water surface, determine the hydrostatic force in the pressure center. Specific gravity of seawater is 1.025. Okay, so again, FR is P average times A. We know P average is rho g HC. We know the area of the window is pi r squared. We know HP is HC plus YC over HC times A. And for a circle, you can again find this. IC is pi r cubed over 4. Okay. So that should be pretty straightforward, but just gives you an idea of submerged without an angle. All right. This last one is bonus. And I believe, I don't know if I have a video on this. I might. But let me help you with this anyways. So we have a gate. It's hinged at A, and it's resting at B. Okay. And we want to find the force exerted on the plate by the ridge. All right. So basically, there is a force, which we're going to call FB here. Oh, sure. That's what we're looking for. There's a hydrostatic force acting because it's water down 2/3, which is there. And then we have AY and AX. And again, FR is P average times area. I believe it says it's 6 meters. So this is basically, you're only looking at the water level. And this goes back. So it's 5 meters in and out of the page. So we know the area. P average is rho g HC. We can find HC from the water level down. We know the density. We can use specific, is there a specific gravity on this one? Nope. So just use regular water. So do 1,000 kilograms per meter cubed. And then we now have this force, right? And then you could take the moment at A and set it equal to 0. And you can then figure out with the moment equation what FB is. Okay? Because remember, when you take the moment, these two terms will go away if you take it at A. So you're just left with FR and FB times distances. Okay. That should help you with homework 4. Good luck, and let me know if you have questions.